I'm going to tell you about diagnostics in JavaScript, mainly about Node, but the thing I wanted to start with, if it's clicking, yep, is who this is for. Because Summit is mostly front-end developers, and I'm totally aware of that. So this is going to be useful to front-end developers, because even if you're doing front-end, you're probably using Webpack or something, and it's actually running on Node. So your build may fail or run out of memory, and this is going to be useful to you as well. And at least half of what I'm going to show also applies to your front-end, where you can debug things using the tools in a very similar way. So yes, we're starting at a point where you already have an application. You wrote something, you're a productive developer. You built an application, you want to ship it, it works in production. This is what we talked about on the previous summit, if anyone remembers my previous presentation. Now it's time to, hello? Now it's time to dig into details of what's happening in production. And this is what I knew about diagnostics in 2012. Still useful, but very lacking if you really want to diagnose your performance or find bugs. This is the worst thing you can do. And I'm going to focus on showing you the tools I hope you would use when something wrong started happening around your application. Let's go through some problems and ways to diagnose them and to find out where they're happening. So the first problem is general CPU performance slowness in general. So you might want to look for performance improvements, but not necessarily. As my Java developer friend would always say, developers are more expensive than hardware. It's worth remembering. So you might want to scale before you go and start hunting performance issues, just for the record. But if you already have a performance issue you want to track, you can use console time, which is a fairly old API available in Node and browsers. So you give the timer a name, you start the timer, you end the timer, you get a log of what the timer measured. Easy. Now, in Node 8.5, so 2 weeks ago, Node actually shipped with performance timing API. The guy who wrote it is not in the CTC anymore, but that's complicated. I'm not going to get into it. I'm hoping he is still going to contribute and refine performance hooks. These are experimental, a bit more verbose, but they give you way more power to measure things. So you put marks in your code all over the place, and you can measure time between the marks, no matter which of them they were. So it's easier to track problems. You don't have to know where to expect them. And you can change the code faster to introduce measurements. OK, next up is Profiler. So you have to run your application with specific switches. By the way, inspect switch is not experimental anymore. And you're actually opening DevTools in your browser. And there's this magic Node button that will show you available running Node processes in your system. And you can go to Profiler tab, start, stop. You get a profile of what happened during the time when you clicked it. And you go through sections of the profile, and you see which module or file actually spends time on the timeline. This is a big tool. Sometimes you don't want to go through all of this. So --prof is a very old one, but it's still useful. It gives you results where you just get percentage of time spent in certain functions. And it's surprisingly useful. If you have an issue that there's one performance issue in your app, and you can pretty much tell what it is, but you want to pinpoint it, this is very good. And if it's more complicated, you want to go with flame graphs. This is the ultimate performance measurement. And the best part is it's fairly easy to get a flame graph from production. You can have a process that's been working for the last 2 weeks, and you noticed some performance issues. You don't have to kill the process and restart it with new arguments. You just go into production, you type the right command, and you get a bit of profiling data which you can generate a flame graph with. And I'm going to show you an example. Maybe the cleaner one. OK, now this one's cooler. So yeah, we're loading a flame graph. I hope it doesn't depend on web fonts or something. So this is an HTML page that gets generated after you type the 4 commands you need to. And you get a huge stack of stuff that's happening. And as you can see in this particular app, the biggest chunk is here. And if you go through this stuff, I can click on something. And then there's a close-up in here. And this tells me the actual culprit. It's one of the examples I'm going to mention later, but this is a direct path to a module that does a lot of synchronous operations. So it generates the wide bar. And you can get those from production. It's very cool. OK, next problem, before we run out of time. So if your app tends to hang up and stop accepting calls, this is a fairly known problem. You should be aware of that. So raise your hand if you are aware that you shouldn't have a long for loops in Node or in JavaScript in general. OK, more? This is important. So JavaScript is single-threaded. It has an event loop, which is running your code. And unless you run something with a callback or promise or anything, a regular loop will block the process. So no incoming requests accepted. If you run while true in Node, it's not going to accept any incoming HTTP request because it's busy. And this is exactly what happens. So first, you need to detect those situations. Long synchronous operations block your event loop, and you need to know about it. There is all kinds of commercial tools for monitoring your Node.js stack you can connect. And this is one of the main metrics they offer. But you really don't need any paid solutions for that because there is a very old and very good module called Blocked, which is a cool hack that measures time it took to run another event loop cycle and lets it know if it was too long. So once it happens, you need to find out where. And you can use flame graphs or profile the app to notice what's taking a lot of time, if you can trigger it a lot of times. But if it's not that easy, well, we didn't have a good solution for it for quite a while. But that's not true anymore. It was hard to find, but with Node 8, there's async hooks. And async hooks give you the possibility to plug into your application and detect where asynchronous operations start and end. So everything between start and end was effectively synchronous, and you can measure time. And I use it to re-implement blocked, hence blocked-at module on NPM, recommended. Full disclosure, I wrote it. And I wrote some tests. That's good. And this is what it looks like. So you don't just get a notification that, hey, something happened. You also get a stack trace pointing to the beginning of a function that had a long synchronous operation somewhere inside of it. So this gives you a chance to find out. And yeah, Node 8 is going to be LTS in a month from now. So if you also have a policy at work to only use LTS, you can start using it in a month. Or you can run a small testing environment for your app. But this is very good for monitoring. And If you find out anything about blocked at, let me know. I'm out there to help. Also, async hooks. Very cool thing. It's not just for detecting event loop issues. You can generate a whole graph of everything asynchronous in your application, all the dependencies between asynchronous calls. Very cool. OK, next problem. This is going to be obvious, I hope. If your application is using too much memory and the usage is growing over time, it's not good, right? It means you have a memory leak. And memory leak is something you can easily notice. You probably don't even need tools for that. But process.memory usage, also available in the browser, but under a different name. It's window.performance.memory, as far as I remember. Lets you know what's the current heap size. And this is very effective for monitoring. But then you need to find the leak. So if you want to find the leak, you need to use the Heap Dump module. Or in the browser, you do the Heap Dump on your own. And then you use DevTools to compare that. And it's actually a long topic if you want to run this in Node in production and build up the whole tools setup. But I can show you that in the browser. Yep. OK, so we go to performance. And yeah, they moved it to memory with this update. OK, fun. And console is not going to be important. So we have heap snapshots here. So I'm going to take a heap snapshot. And then, yeah, it loads. And then I'm going to move around, hover for a second, go back to profiles, take another snapshot, select the second one, zoom in so we can see. This part is going to be interesting, hopefully. So I select the second snapshot. And this is the most important element in this development tool. You choose comparison in here. And this is when the fun happens. So you get the information about what's new in the current snapshot compared to the previous one. This is the only thing to remember. You click here, choose comparison. And you can now find memory leaks. OK, close. Thank you. OK. That was quick, right? It's almost as easy with Node. Next problem. Your application crashes. If it crashes, it says crashed with a core dump. Who knows what a core dump is? Yeah, and you probably know it from C++, right? Thought so. OK. So if an uncaught exception happens or something breaks or you run out of memory entirely, these are the reasons why you can get a core dump. And with that, you need to diagnose it. Before you get a core dump, it's worth looking at Node report. It's a package you can just add to your application. No functions are called. When the app finishes, it's going to produce a file that gives you some basic diagnostics, like what's the last function that was called, what's the current stack, what's the size of memory, etc. But if you end up having to use core dump, this is where it gets really interesting. Sorry. This thing is not for the people with long hair. OK, you need to remember to enable making core dumps in your system. And that's basically how it gets started. And then you analyze it. But this is a longer topic. It's a topic for a workshop. So I'm not going to go through it yet. But you do have some reasons for an out-of-memory crash that can be fairly obvious. Let's go through them. So Node will crash if you allocate more than 1.5 gigabyte of memory, because that's the default configuration. Why? Garbage collector has trouble dealing with more than this, and it's less efficient. So it's not worth using this much RAM. You should be on microservices anyway. So if you have a memory leak or a bug that correctly allocates enough memory, then your app is going to crash and say there's a core dump, but you don't need it if you already see that it allocated a full 1.5 gigabytes of RAM. Also, if you have an infinite asynchronous recursion, it's fun. You can just start queuing functions one after another and make a gigabyte of that. Also, it happens with promises if you try very hard. And this can happen if you work with streams and you put a big file through Node, and the receiving end is too slow. So it adds app and takes enough memory for the whole process to crash. But this is very rare. OK. These were the most common problems you can find when running Node and ways to diagnose them. I'm actually attending some of the Node.js Diagnostics meeting and digging in ways old and new to figure out what's happening to your application. And I'm writing all of this in one place on GitHub. So feel free to click on this link. I'm going to post my slides in a minute. And there you can find tutorials and examples. And I'm also planning to do workshops on that, so you can follow me for news about workshops. So yeah, thanks for listening, and I hope you had fun. Now we can do Q&A, or we can do some demos. So raise your hand if you prefer to do Q&A. 2, great. Raise your hand if you prefer to do demos. Democracy. OK. So one cool demo I can show you is going to be creating a flame graph. So I hope you can see these. Yeah. So what you need to do to create a local flame graph from the process that you can run locally, you don't have to go to production. You can run this crazy long command on your application. And it just enables the right things and writes correct output to some files. Then this is the part of my example that actually triggers something happening inside of the app. You can find this on GitHub also. And it's these are spoilers, so sorry. This is the spoilers file that shows you how to solve the task. But this is actually a task where you can learn how to profile your application. And then you analyze your performance data with this line. All the stuff in red is actually to make the output cleaner. So it's a trick. It's not necessary. All the pipes in there with sed are absolutely not necessary, but the output looks a bit better. And then you run stackvis, which is an NPM module, on the output. And you create an HTML file, which is exactly the one that you've already seen. And I can run this script right now to show you that it actually works. Yeah, but without typos. Demo. OK. There's some interesting output if you look carefully. When I run my application, this is what the application says. So this was a console log from Node, go to localhost and generate some traffic. And then this is output for the performance tracker. So it said that it was waking up every now and then to collect data points from your application. And the only thing it really does is it checks the current function that's being run right now. That's all. And it collects samples. It collected a megabyte of samples. And then I ran stackvis. And then I can do Chromium browser flamegraph.html, boom, and it opens. And it's 3 megabytes of HTML, so it takes a while. And here's the flame graph. And this was the example with a few more settings where it's not that obvious. So the one you saw before was a very obvious one with a long bar. Here you need to put some effort into debugging it. So you go into this bytecode handler, scroll up, and go through these and look for details. I'm not saying it's something you would give a 12-year-old and forget about it for half an hour and get results. But despite how it looks, it's actually not that hard. A while ago, you needed to run Solaris on a virtual machine to even be able to generate this one. So we've moved forward a lot. I think I ran out of time, including Q&A. So thanks. If you're interested in more examples or a full workshop, follow me or get in touch. I'm hoping to run 1 or 2 this year. And see you later. Thanks.